All right, so this is for Unit 4, Topic 1, SLT 5. We're going to be talking about how to write the equations of circles in standard form. For your warm-up today, you're going to write the equation of a circle whose diameter endpoints are -2, 1, and 4, 3. This was a lesson that we did on Monday of this week. Your homework is, of course, page 28 and 29. That is due for you today. So please make sure that is submitted on the portal. If it's not, go ahead and get that done before we go over the homework and the lesson here. Your PC review is going to be due on Tuesday of next week. There'll be a video / answer key posted for that so that you can go over that. Your progress check is going to be next Wednesday and Thursday. All right, so if you haven't had a chance to try the warm-up, go ahead and do that now. Pause the video, give about 2 or 3 minutes to work on this, and then unpause the video. All right, so if we're going to write the equation of a circle whose diameter endpoints are -2, 1, and 4, 3, we have to use our two formulas, which is the midpoint formula to find the radius, and then the distance formula to find the length of the radius. So in order to, again, find the center of the circle, I'm going to use the midpoint formula because that will tell me on the circle, again, little quick picture over here, -2, 1, that would be about here, and then 4, 3 would be about here. So if this is my diameter, I know that the center of my circle is about halfway across it. So finding the midpoint will actually help me find the center of my circle, which is going to kind of look something like this if it were sketched on the coordinate plane. Okay, so finding the midpoint of the diameter will help me be able to determine what that center point is. So my 2 points are -2, 1, and 4, 3. Again, this is x, this is y, this is x, this is y. So in order to use my midpoint formula, I'm going to take my 2x values and add them together and divide by 2. Then take my 2y values, add them together, and divide by 2. And that will then give me my midpoint of 1, 2, which you can kind of see here in my picture. That looks like it would be right around 1, 2. Now, I need to find the length of the radius. So I can use either, so I definitely need the center and an endpoint. Oops, I meant an endpoint. So my center point is 1, 2, and I'm going to use the endpoint 4, 3. Again, it doesn't matter which one you use. You could have used -2, 1 as well. But my distance formula is the square root of my 2x values. So I'm going to do 4 minus 1, subtract them, and add then my y values, the difference of those, 3 minus 2, so 3 is my 1y value, minus 2. Just make sure you stay in order, so since I used the 4 first for the x's, I'm going to use the 3 first for the y's. So I did 4 minus 1, and then 3 minus 2, and again, you got to square that. So then you can put this right in your calculator. 4 minus 1 squared is going to be 9. 3 minus 2 squared is going to be 1. So I know that my radius is the square root of 10. Or, yeah, that's my distance. It says distance. Maybe I should use r for radius. But I'm using d because that is the distance formula. All right, and then I'm going to write my equation. So I'm going to take my x value of my center, which is 1. And I'm going to put that in right here. So I'm going to use the opposite sign. So since that's a positive 1, I'm going to put in -1 squared. Then I'm going to use my y value, which is right here. That's 2. So I'm going to put in a -2 here, squared. And then my radius, which is the square root of 10, squared. Now, remember that if you square a square root, it's just going to be that value. So really, I don't need to write the square root of 10 squared. I could just write this equation as 10. Because remember, if I square a square root, then that's just going to be the number under the radical. So there's the equation of my circle right here. All right. So today we're going to be taking equations that have an x squared and a y squared in them, and we're going to be putting it in the form of a circle equation. Before we do that, we're going to go ahead and check your homework. So at this point, you should have already submitted your homework on the portal, MCPS Canvas page. So we're going to go ahead and check this. If you want to go ahead and pause the video here, that way we can check the homework. Give about a minute here to check. Okay, we're going to move on. And again, pause this here for a minute. Allow to check. This will also be available. This video will also be available in the module. So if you wanted to take a few more minutes to check over this, also the paper PDF notes will be posted in the module as well, so you can look at it there. All right, and last page here, number 5. Again, pause the video. All right, we're going to go on to page 30 in your packet. So if you could go ahead and get out your packet and turn to page 30. We're going to do a quick refresher for completing the square. So remember that if I have whatever my b term is, I'm going to take half of that and square it, and that is what I'm going to put in that blank to complete the square. So here I'm going to put a 16. Here I'm going to also put a 16 because half of 8 is still 2, and squared is 16. Half of 14 is 7, and then square that is 49. Okay, and same thing with this one, that's also 49. All right. So in order to get what basically my perfect square is, I could factor this into x plus 4 and x plus 4. However, over here, because this is a minus sign, this is going to be factored into x minus 4 and x minus 4. So when I write them as my perfect square, I have to make sure that I have the right sign for each of them. Okay, so that's what we're going to be doing today. That's the lesson, completing square, that you did on Tuesday, and we're going to use this skill in order to complete the square and solve equations. Okay, so we're going to go over to page 31 in your packet. So if you could go ahead and find page 31, we are going to go ahead here and complete the square for these equations. Now, these are the beginnings of a circle equation. The reason why they are the beginnings is because notice I have an x squared and a y squared in this equation. So any equation that has an x squared and a y squared like this is actually the equation of a circle, and we're just going to go ahead and put it in the form of an equation of a circle. Now, if you remember, when we did completing the square, we had to get ax squared and bx on one side, and then we always got the c value on the other. So that's not going to change here. We're going to basically take and put all the x's together first and then get the constants on the other side. So what that would look like for this equation is I would first start by subtracting 24 from both sides. And then notice that I have a 14x, a plus 14x. So that's going to go over here with the x squared. So I'm just going to move that in the equation. So I'm going to start here by doing x squared plus 14x. I'm going to leave a blank. That's going to be where I complete my square. Now I'm going to write my y squared, and there's nothing else that really goes with y squared. So do I really have to complete the square with y squared? No, because this is like plus 0x. So there's nothing I really have to do because there's no y term. There's only a y squared. I won't have to complete the square for the y squared term. And then this is going to be minus 24. Since I have one blank over here, remember, whatever I do to one side, I have to do to the other. So now, how am I going to complete the square? Well, I'm going to do half of 14. So half of 14, here's my 14. I'm going to do half of that and square it. So I'm going to put a plus 49 here. And remember, if I do it to one side, then I have to do it to the other side. So I'm going to add 49 to both sides of this equation because I completed the square on the left side with the x terms. Okay. Now, what did I do to complete the square? Well, I could factor this, and the two numbers that when I add to get 49 multiply to get 49 and add to get 14 is 7. And I could just write this as x plus 7 times x plus 7, but what's easier than writing x plus 7 times x plus 7? Well, I can just write x plus 7 and then with a squared. So I don't need to write all that. I can just put a squared here. Now notice I also have my y squared. I'm just going to bring that down. And then negative 24 plus 49 is going to be 25. So I just put those two things together. If you notice, I now have the equation of a circle. Okay, and I can find what my center is. So my center is HK. So in this case, my center is negative 7 and 0. So the negative 7 comes from the x plus 7 term. And then my y squared, because I'm not adding anything, is a 0. And then my radius is the square root of 25, or just 5. Okay, so that was a fairly easy one because I only had to complete the square one time. Let's take a look at the next one. On the next one, notice I do have this time an x squared and a y squared term. So I have an x squared here, and I have a negative 8x term. And then if I'm looking for my y's, I have a y squared term and a negative 8y. So I'm going to put those together, and then I'm going to get this constant number on the other side. So that's my first step. My first step is to group the x's and y's together and get the constant on the other side, just like we did with completing the square in class. So I'm going to then say x squared minus 8x. Those are my two x squared terms. Leave a blank to complete the square. Then y squared minus 8y, leave a blank to complete the square, equals negative 23. Because I have two blanks on the left, I need to put my two blanks on the right as well. So that's the setup. All right, now I'm going to complete the square for x squared. Well, I'm going to take half of 8 and square it. So half of 8 is 4. Square it is plus 16. Then I'm going to take half of y, it is again a negative 8y, and square it, so that's a plus 16. Remember, if I do it to one side, I also have to do it to the other side. All right, now I'm going to write the perfect square term. So what did I get when I took half of negative 8? I got negative 4. So this is going to be an x minus 4 squared. Again, that's where the factoring comes in. That's what we did in class on Tuesday. Same thing here. This is going to be a plus. Actually, I'm going to write my plus in black. That's going to be a plus, and now I'm going to factor my y terms. And this is going to be the same thing because notice it's the same exact factors. So this is y minus 4 squared. And now I'm going to combine all of my like terms on the right side here. So negative 23 plus 16 is negative 7. Negative 7 plus 16 is 9. So now you can see you have a circle equation because you have an you have a perfect square binomial with x's, you have a perfect square binomial with y's, and then you have the constant on the other side of the equals. So here my center would be at 4, 4, and my radius would be at the square root of 9, which is 3. Okay. All right, let's do one more here. Same thing with this one. We're going to complete the square. If you want another practice, you can do 26, but we're going to do 25 together. All right, so again, get your x's together. So that would be x squared minus 8x. Get your y's together. Leave your blank. Y squared minus 8y. Leave your blank. Moving the 31 over to the other side would be a minus 31. Complete the square. Half of negative 8 is 4. Square it, you get 16. If you do it to one side, do it to the other. Complete the square for the y term. Half of negative 8 is 4. Square it again, you get plus 16, just like the other example. And now you're going to go ahead and simplify here. What did I do when I took half of negative 8? Remember, that's what's going to go here. That's factoring basically this trinomial, two numbers that when I multiply I get 16, and add to get negative 8 is negative 4, negative 4. Instead of writing x minus 4 times x minus 4, I'm just going to write x minus 4 squared. Same thing for the y terms. This is again going to be x minus 4 squared. Negative 31 plus 16 is 5. Nope. 1, my bad. And now you have your equation of your circle. So my center is again at 4, 4, and my radius is the square root of 1, or in this case, just 1. All right, I'm actually going to do 26 with you just so that you see a little bit different numbers for completing the square. So I will go ahead and do number 26. Again, get your x's and y's together. I don't have any other x terms, so I'm just going to bring that down. I know then that that's going to be a 0. My x value of the center is going to be a 0. So if you wanted to go ahead and write that down, I know my x value of the center is going to be 0 because it doesn't have any other x. I will have to complete the square for my y terms, and then bring your constant to the other side. Okay, take half of negative 18 and square it, that's 81. And if I do it to the left, I do it to the right. And now you can really clearly see I have an x squared, that's my center 0. If I factor y squared minus 18y plus 81, that's going to be y minus 9 squared, and then this is going to be 1. So my center is at 0, 9, and my radius is 1. All right, so what you're going to work on now for the rest of class is the matching activities on the next couple pages. So if you look at, you can do a couple more there if you wanted to. You're going to go to page 32 in your packet, and there's a matching activity. You can work with a partner, and all of these equations are in standard form of a circle, okay? And what you're going to do, let me get this, okay? Your capture sheet is page 32. You're going to match each numbered equation with its lettered form, okay? So you're going to take the original equation that you're given, and then you're going to put it into standard form and match it. This is kind of like your answer bank, okay? So work with a partner. You're going to go ahead and on page 32, you're going to show all your work on page 32, and you're going to match the numbered equation with its lettered form of the version that is not in the standard form of the circle. All right. All right, let me know if you have questions. You can come to me, Ms. Conway. I'm in room C216.